Hello! So today we will find area under this curve or area of this shape which is bounded by this green line, second green line, this curve, and our origin of axis, which is y equals 0. First thing what we need to do is to simplify this shape. By doing this we can estimate area of this shape or area under this curve. We just draw rectangles inside this area. So for every rectangle, the width of it will be delta x. So the height of every rectangle will be a point on our curve minus y at this value, which is 0. So we can say that our height, delta y, will equal to y2 minus y1, which will equal to this. y1 is 0, so that means delta y will equal to the point on our curve, this point. This will be for first rectangle. So I'll just make it like this. Then height of second rectangle will equal to the point on our curve. For example, this point. This is very bad representation, but so just remember that height of every rectangle will be point on this curve that is falling on our y-axis. So that means area of this shape will be approximately equal to area of first rectangle, which is this one, plus area of the second rectangle, this one, plus and so on until our last rectangle, area of our last rectangle, which is this one, and this will be area of our shape. But this is approximately, and it will depend on our delta x value. We will take a look at this a little bit later. In other words, we can write it like this. Area of our shape will equal to this sigma symbol, which represents our sum of every area of rectangle with an index of I. Index of I first will be 1, then second index will be 2, until we get to n index, which is the last rectangle. But this formula can be written also like this. So I'll write it here. So what is area of rectangle? Area of rectangle is width times height, but width for every rectangle is same because we said so. So let's write first height of our rectangle, which we remember from here. It'll be value of y at every rectangle with an index of I, and times delta x, our width. So this formula can be written as this. But what will happen if we try to minimize this delta x, or let's say delta x is a very small number? It will essentially approach 0. So what we can say about this? So we can write this equation in different form. We'll use limits. So we say limit where delta x approaches 0. It will approach 0, but never come to that value. It will be very close to that value. And we take limit of our sum. So again, why did we do this? First of all, because L delta x, we need to approach it to 0. It's not 0, but it approaches 0. And second, because our area can be infinitely large, and it can just be infinity, so we need to limit it to some value while approaching delta x to 0. What happens when we make our delta x very small? So that means we will have more and more rectangles. So for example, let's take this rectangle. So what we did here, we made essentially delta x a little smaller, and we got 2 rectangles. So when we make delta x very small, that means our n approaches infinity essentially. So we'll have many rectangles. So that's why we actually limit our value to some reasonable number. And this limit actually can be called something that we already know, we know today, but it was discovered by, I think it was Leibniz or Newton. Someone between these guys discovered this, and they called this limit integral. So it will be symbolized, it will be represented by this symbol, where at the bottom we will have a lower value, at the top we will have upper value. So what is lower value? It is x1. What is higher value, upper value? It is xn. So from x1 to xn, I just called them x1 and xn, but they can be also called a and b. And we take integral of our y, or we know that y is also represented by this f of x, which just means function of our value x. So I'll just write it like this instead of y. Also, we need to multiply this value by our delta x, but here we will just say that it is dx, and dx represents very small number. As I said, it approaches 0 but never reaches 0. So yes, this was integral and how we can maybe find integral. This is not perfect. I am not sure yet how to, for example, solve these integrals. Of course, we know right now, but I want to approach to this concept as it was approached by Newton or Leibniz or any other person that discovered integral. I think it was Newton or Leibniz because they did it independently at the same time. So yes, I want to make it something like this. I couldn't find any information about this discovery. Maybe it can be found in the Principia Mathematica of Newton's book. I didn't look at it. And of course, if you know how to solve this problem, you can just write it in the comments down below. I will read it and maybe make a new video about it. So yes, thank you for watching and we will see you next video.